Alright, so let me take you back a couple lessons ago when we started some of these chapters where we started graphing lines. This is a linear equation. Notice the highest power of y is 1, highest power of x is 1. So what makes it a linear equation, more or less. And the way we did it before was by plotting points. You just make a little chart here. You write down x and y values. For example, if x is -1, you would calculate -1 times 2, added to that, that gives you -5. And that you would make a little dot at -1, -5, 1, 2, 3, 4, 5. Then you could calculate another point, 0, that gives you -3. At 0 it goes to -3. At 1, if x is 1, that makes y -1. So when I go to the right one, or down 1, when x is 2, that gives you 4. Take away 3 is 1. And so, after a while, you just simply connect the dots. That's how we did it before. That's called graphing by plotting points. Okay. Now that's great if you're a beginner and you got nothing else going on. You can always rely on plotting points. But what we'd like to do here is we'd like to make it maybe take it a step further. And try to think about these lines in a more methodical way rather than just plotting points, which is great if you got nothing else going on. But if you can, try to think about this, okay? So let's forget all this. Let's undo it. Well, maybe keep that there. The idea here is to note a couple things. Really, if this is in fact a line, you identify the equation, that's a line. Really, all you need is 2 points. That's it, 2. As soon as you draw the line through 2 distinct points, that's all you need. You don't really need 10 different points. Although for a beginner that's okay, just to make sure they all line up nicely. But if you already know it's going to line, all you need is 2. Euclid said in his famous book, the Elements, said two distinct points determine a unique line. All right, whatever. For us, let me tell you, whenever you see an equation written this way. This is a famous way of writing an equation. It has the following format. It looks like y is equal to mx plus b. A number here, the coefficient on x plus some other number. Every single time you have an equation written that way, it tells you something very special right off the bat without doing much work. Let me explain what it tells you. First thing it tells you is one easy point on the equation. Here's the easy point that it tells you. If x is equal to 0, look at that. If x is equal to 0, you've killed that and you've got your y coordinate for x equals 0. Y would be -3. You see that? Let me do that again. First of all, let me get rid of this just because it's distracting. And let's get rid of this. Do it over again. Again, if you have an equation that looks exactly like this, it tells you something very important right off the bat. It tells you one of the points on there really easily. If x is equal to 0, this gets killed, and so you just get -3. Already it tells you that the line has to go through this point right here. This is called the Y-intercept, because this is the y-axis, and you know that the line has to intercept right through here. You already know something about the line. You already know that it has to go something like this. But the one thing that you don't know is how steep. Should it be this steep? Whoa. Just a second. Should it be this steep or that steep or that steep? I don't know how steep it should be, but I know it has to go through that point. The only thing we gotta figure out is what's the steepness. Okay. But for that, we have a very special tool. We can figure out the steepness if we just figure out one other point on the line. We can figure out the steepness. And to figure out that one other point, what we do is we plot just one more point, and that very special point is we move x over 1. And if you move x over 1, for example, think about what that means. Moving x equals 1, that makes 1 times 2, makes it 2, plus a -3, that makes it -1. So in terms of the picture, what that means is if you move over x1, your y had to increase by 2, so now you're up 2. This is the new point, 1, -1. Okay, what happened is you increased x by 1, and y had to be increased by 2. Had to move up 2. And that's enough. That's all you need. Now you can tell that the line goes exactly this way. And that's it. The line is completely determined by those 2 points. Now, what I want to point your attention to is the fact that the information that we needed was already there, staring us right at the face. The slope is equal to 2, and the y-intercept is equal to -3. This is called the y-intercept. This is the slope. Meaning that there was nothing special here. You could play this game every single time. Let's try that again. This time, let's try to graph 2x plus 1. Y equals 2x plus 1. Again, all you really need is 2 points. That's all you need for a line. So the one very special point that you can always choose is x equals 0. What that does is it kills this part of the equation. Immediately it tells you that y is equal to 1. And whatever number is over there, that's your y. That's famous. That's going to be your y-intercept, meaning that the line has to go through the point 0, 1. And already your line is almost determined, and you know it's got to go through here. The only thing you don't know is how steep is it? What is the slope? Is it this steep, that steep, that steep, that steep? What's the steepness? For that, you can plot another point. Later on, we won't even need to. All you do is look at that and realize that the slope is 2. But just for now, let's plot one more point. If x is equal to 1, that increases the y value by 2. That would make this 3. Meaning that if you go on the x, you go over 1, now you have to go up 2 for a total of 1, 3. And the line has to go through there. Just like that. Okay, again, most of the time it'll be even easier than that. All we do is look at the slope and you look at the y-intercept. That's it. Here, I'll do it one more time. Suppose you wanted to graph y is equal to, let's try something different, 3x plus 1. The 1 tells you you're going to go through the y-intercept, y is equal to 1. The 3 tells you the slope, rise over run, right? 3 is the same thing as 3 over 1. So that means you run 1 and you rise 3. There it is. Ran 1, rise 3. Boom. End of story. Completely determined just by that. Okay? Again, I'll do it again. Suppose you have y is equal to 2 over 5 x plus 3. First, if x is equal to 0, you know y is equal to 3. So therefore, it's got to go through exactly this point. The next thing you know is that if you rise 2, you have to run 5. If you rise 2, you're looking at this. This is the slope. You rise 2, you run 5. So if I run 5, 1, 2, 3, 4, 5. I ran 5. You rise 2, 1, 2. See that? 5 over 2. Run 5. Rise 2. There's my steepness, and now all I got to do is connect the points with a straight line. There it is. See why they pay me? So they're so simple. Every single time that you've got the equation written like this is a famous way of writing the equation. It's called the slope Y-intercept form of the equation. When it looks like this, y is equal to mx plus b. Every single time the equation is written like this, it should take you about 2 seconds to graph that. The b tells you the point on the y-axis that it's going to intersect, and the m tells you the rise over the run, the slope of the line. That's all you need. So here's another way to say it. Instead of needing 2 points, another way to graph the line is just 1 point and the slope. As soon as you know 1 point, all you really need is the slope. Any point on the graph. If you know that it goes through that point, all you really need then is the slope, the steepness, and you're done. So Euclid said any 2 points determine a line. It's great. We can even change that a little bit. All you really need is 1 point and the slope. Here's the 1 point and the slope, and you're done. Alright, let's try that one more time. Let's try some negative slopes for fun. What if we have y is equal to negative 2 over 3x plus 2? Alright, 2 seconds to graph that. First thing you notice is this 2. The 2 is the y-intercept. In other words, if x is 0, y is 2, you know it's got to go through there, 0, 2. The only thing left to determine is the steepness. But for the steepness, all you do is look here, and there's the steepness. The rise over the run is telling you the run is 3, the rise is -2. So if I go 3, 1, 2, 3, the rise is -2, 1, 2. So it's got to go through that point. And that's it. Once I've got 2 points, it's all over. There's my line. See how easy that is? Instead of plotting points like the way we did the very first day we learned to plot these, we look at it much more methodically by looking at two key ingredients. The first key ingredient is the point on the line, which is the Y-intercept, and the second ingredient, the steepness. Once you got those two key ingredients, it's all over. Let's do that one more time. No, let's do that 100 more times. Not really. Alright, let's do that one more time. Suppose you wanted to graph y is equal to 1/4 x minus 3. 2 seconds. All you need is first key ingredient. It has to go through -3 on the y-axis. That's the y-intercept. 1, 2, 3. You're almost done with the line. All you need is the steepness. For the steepness, all you do is look at here. 1/4. Rise over run. So you run 4. 1, 2, 3, 4. You rise 1. That's it. And all you need is then you just draw the straight line going through those 2 points. And you're set. There's your line. Graphed using the famous, super famous Slope Y-Intercept form. Okay? You like that? One more? One more? Why not? Alright, how about y, let's graph this one. Y is equal to 3. Whoa, whoa, whoa. This one doesn't have the mx plus b form, apparently. Every time you got one of these, you can think about it as a special case or not. These are especially easy because no matter what the x is, the y is equal to 3. So 1, 2, 3. No matter what the x is, the y is equal to 3. So every one of those, the y value has to be 3. So you know that it has to be a horizontal line like that. I should always use my little straight line drawing device. There it is, y is equal to 3. That one's a little special case. A little different. The other one that's a little different is if you have something like this, x equals, for example, 5. Then no matter what the y value is, the x is equal to 5. So 1, 2, 3, 4. This is where x equals 5. That is where x equals 5. That is where x equals 5. This entire line is where x equals 5. This one is the only exception, cannot be written as mx plus b form. And this is a vertical line. So that one, again, is a little different than the other ones. But you can still do it. Vertical line. By the way, what's the slope on this one? The slope is infinite or not real. What's the slope on this one? The slope is 0. It's got no steepness. Actually, this one could be written as mx plus b. You just go like this: 0x plus 3. Technically speaking, that's correct. The slope is 0. The y-intercept is 3. This one, on the other hand, you can't never write it mx plus b form. This is the only exception. You cannot, because there is no slope. Slope is not a real number. So when you go on and you try to write this mx plus b, there will be no real number that you can put there to make this work. So this is the only exception. You can't write it in mx plus b form. Everything else, it's a piece of cake once you write it in mx plus b form. Okay. I think this video should be enough, man. This is an easy one. Super easy. Now you guys got to do the homework. Okay?